Module 11. This week, we will go to the new header file to implement. We call hashMap. So to implement hashMap, we have two different ways. We have the linear probing and the chaining. So you can see it's not like before we say the two way to implement the header file, we use the array implementation and linked list. But hash table, hashMap is a little different. They have two different technology. We call linear probing or chaining. So that's what we'll talk about in detail. What's that for? But the first thing, let's talk about why we need to have a hashMap header file. So to talk about the hashMap, we need to talk about what is the hashCode function first. So if you remember, you just finished your homework assignment 10. So the homework assignment 10, actually, we revisit our DVC schedule. So your DV schedule V3 and your DV schedule V2 from your assignment 5. If you remember, we still do the duplicate check. So in assignment 5, we use the two-dimensional dynamic array. And assignment 10, we're using the associative array. Your associative array in the header file is quite a little work. We need to have that done. But afterward, you only have few lines, you finish the duplicate check. However, I want you to think about your assignment 5 and assignment 10. They have the same or different runtime. So the first thing, let's see our assignment 5. No matter we say is the static array and the dynamic array, we have the square bracket operator function, right? Okay, so that's considered the big O. What is the big O for the square bracket getter or setter in dynamic array or static array? Right, one time, right? Because if you give me the index for an array, just right away using the index, I can find the value to you. So the square bracket, no matter getter function or setter function in the array, the runtime will be 1. But how about our associative array? Did you remember your associative array, your square bracket, getter function, setter function? Do we still have that? We have that, right? But just instead, we passing by index, we passing by the key. So in order to find the match key, so that's why here in your getter function or square bracket setter function, we all have to write a for loop to looking for the match key. So that's why here in your associative array, your square bracket getter and setter, the runtime actually is n. So they are different, right? But your assignment 5 and assignment 10, actually their runtime are quite similar. The reason is even your runtime is 1 in the square bracket getter and setter. But every time when we try to find the match value in the array, we have to go over and for loop, right? So in your header file, your square bracket runtime is 1. But in your main function, your runtime is big O(n). So on the other hand, when we do the searching each time for the matching value, yeah, our runtime still is big O(n). Okay, so that's here for the dynamic array. We are easily to implement in the header, but the main function, we have quite a bit of work to find the duplicate. So associative array, actually, we write more work in the square bracket, getter and setter. So the runtime is n. But actually in our main function, when we try to find the match value, do I have the spring 2019 3666 section or not? I only need the one statement. I see they are returned true or false. I know duplicate or not. So that's why here you have difficult, more complicated header file to write. but your main function is easy and clean. But no matter what, each case, no matter we talk about assignment 5 or assignment 10, the same thing, their runtime, if you just want to find a match value, no matter you use the static array, dynamic array, or associative array, at the end, your runtime is still n. So that's what we want to talk about. How about we can combine these two together? You do love the key, right? It's easier in the main function. I just search for the key. So then my statement, duplicate check, okay, done, one statement. But how can we make our duplicate check, our searching in our associative array instead is big O(n), can I become big O1? So that's why we want to combine together, right? We really want to hope we can find a way. Here in our main function. In our main function, when we want to searching for the match value, right? So here is one statement, okay? So I want to use the key. So using the key, I don't need to have a for loop to check the value. But on the other hand, I have one statement in my main function. It's possible in the header file, I can pass in the key, but this key can right away convert become an index. So if you have the index for this key, your runtime become what? Right, your runtime become big O1 if you have the index. Remember, that's earlier, right? Whenever you have index is the value, you can have one time just right away find the value in the array. So that's why here, that's our hash map will do. Our hash map will find a way is, you give me a key, but when I do the searching, I will try to convert our key become an index. Any array, if I have index, the runtime is 1. So that's why we call the hashCode function. Before we can implement our hash map, actually we need to have a hash function concept. So what is the hash function? So the hashCode function is, I will convert a key into an index. So this one, once our key can convert to the index in our header, my runtime to searching for that will be 1. So that's why before we implement our hash map, we need to have a hashCode function. This hashCode function, like earlier we said, anytime you pass in a key, I give you an index. So that's the hashCode function. Hashcode function, the return type is always an int because I want to return an index. So then the passing parameter depends on your data type for your key. So we see the example. What is the hashcode function? Okay, so actually your key, remember we can have any key using the k data type for our key. So how can we convert the key to the integer? We just see here, remember, did you remember we have our associative array? Our example is we have the student name, okay? So now here, actually, when you want to convert the key, we just assume now our key is a string, is a username, okay? So how can I convert the username? Like my phone book, right? My phone book, I want to find my friend, Joe. So I pass in the key. But can I convert this key, the string data type, become an int? Yes, you can. How about when I see it's a string, right? Okay, I just convert any letter. Any letter, they have their ASCII value. So J, O, and E. So then, for example, if I want to have the string, I want to convert to the ASCII value, right? I just need to find each character their ASCII value. For example, J is 74, lowercase o is 111, then E is 101. So then add them together, right? I can convert Joe become a index value. Does that make sense? So then this one is, here is what earlier we say, the hashCode function, if I have a string I want to convert to the index. So we can do like this way. So this one we call the hashCode function. Hashcode function is the return type is int. So your passing parameter is the key. So now that's why here earlier our hashcode function, when I want to use the hashcode function. So when I want to use a hashcode function for the key data type is a string. So then you see, remember the return type always int, right? So then what I do is I just have all the string that have each letter. So that's why here we just have a for loop. For I equal to 0, I less than the key. Okay, so then I just have each character. So when you have each character, you try to add the value. The computer will direct to access that value. When they do the operation to the addition, they will convert to the ASCII value. So at the end, I have all the ASCII value add together, so I return the result. So I successfully to convert a string as a key to the int. So that's the example for the hashcode function. So you need to remember your hashcode function actually depends on your key. So your key type is what kind of type. You need to find a way to convert to the int. So we use the string, for example. Here, I give you one more example about the hashcode function. So this example is the key is a string, right? Like we say, key can be any data type, right? So how about now, today my key I want to use the student object as the key. So that's why you need to write another hashcode function for your key is the student data type. So your return type always int. Remember, hashcode function always convert key to the int. So now depends on your key data type, you need to find a way to convert to the integer. So then think about student. Student object, we have name, we have ID, we have GPA, we have many different attributes. Yeah, so that's why here the best int value is the ID, right? So that's why here we just get the convert to the student to an integer, we just return. We're using the student ID to convert to the int. Okay, so do you understand about the hashcode function? So hashcode function, the important thing is they try to convert your key data type into the int. And that's what we need for our hash map header file. So before I show you how our hash map header file will look like, so you need to be careful. This hashcode function, I need that, right? But you can see I need that, but I do need to know what is the real data type for my key. That's why I can show you how should I return that key become an int. So that's why be careful. Your hashcode function, I do need that in my template library. But this hashcode function have no idea to implement before I know the key data type. Because the hashcode function is convert whatever the key into the int. So that's why later when we try to write our template hash map, our hashcode function actually is implemented in the driver program where your main function is. You need to know your key type. Then we need to find a way how to pass this function into our header file. Okay, so that's in our next video. We will start talking about how we will implement our hash map library.